All right, so I decided that I would go ahead and show you how to do these two examples. And this is my first attempt using my voice, so I apologize if it comes across weird or messed up, or if there's outside noises, because I'm not very good at this, but that's okay. So what I did is I created a three-dimensional model for this first example. So this model, so this red side, that's the side that matches the example 1, which you can't see, sorry. And again, this is a work in progress, but we're going to give it a try. So we're going to do example 1, and what I did is I created a three-dimensional model. And so I'm going to refer back to the model occasionally, but mostly I'm going to try to refer to the diagram because that's the thing that you all have available. Now, the very first step should always be to work with the map plan, because the map plan is kind of like the gold standard. This is the thing that leads us to all of our most important answers. So what the map plan does is it's a way of figuring out how many blocks are there. If I were to look straight down onto my three-dimensional object, I'd want to be able to say, well, how many blocks are there in this back corner? How many are in the front corner? And so on. So when I look at this, I can see that this is the level of 1 block, 2 blocks, 3 blocks. So that means in that back corner, we really have 4 blocks. And so if we have 4 blocks there, then we look next to it, and that's 3 blocks. Next to that, we have 2 blocks, and then 3 blocks. Now, a common mistake that some students make is they look at this and they say, well, there aren't any there, so I'll just leave this blank. But the instructions on the test will specify that you have to put a number in every single space. So we're going to put a 0 here. Then in front of this stack of 4, I see that the next stack has only 2 in that stack. And next to that, there's only 1, 1, 1, 1. And then in front of the stack of 2, I see there's only 1 here and 1 here. There's none right there, so we put a 0. Then we have 1, and then we have 0. And then in front of that stack of 1, we have a stack of 3. And then next to it, nothing, nothing, 1. 0, 0, 1, and then nothing again. And then it's important, if the instructions say we have to put a number in every single space, then we have to put numbers here. But if there's nothing in front of the stack of 3, then these are all going to be 0s. So now what we have is the original, the map plan that goes with example 1. What's really cool about this is now we can figure out the volume with very little effort. So what I can do is I can say, well, if I look at this, I can count up how many blocks I have in each stack. So I'm going to go ahead and count across. So 4 plus 3 is 7, plus 2 is 9, plus 3 is 12. I'm just going to write that over here. And then I have 2, 3, 4, 5, 6. And then 1, 2, skip that one, 3. So there's a total of 3. And then 3 plus 1 is 4. And there's none here, and I could write a 0, or I could just say I know that it's none, so I'm not even going to worry about it. Now I'm going to add these together. 3 plus 4 is 7, plus 6 is 13, plus 2 is 15. And then 1 plus 1 is 2. So it turns out there are 25 blocks. So when I built this three-dimensional model, I literally had to sacrifice 25 of my wooden blocks, glue them together to to create this permanent object, which wasn't too bad. So that were 25 blocks. So my volume is 25, and I could put units or I can put blocks. For some reason, I find it humorous to use the word blocks. So I have 25 cubic blocks. So now I have the volume. So this map plan, all I had to do to get my volume was add up all the numbers, which makes finding the volume super easy. Now what I want to do is I want to also fill in these 3 views. And we do have on one of the other pages, on the instruction page, which I'm looking for, but on the instruction page, they actually show you what these 3 views are. So here's the 3 views. So as we look at this object from 3 dimensions, so if I look at it from the front, or from the right, or from the top. Now the coolest thing is we can do the top view easier than any other view for the map plan, because all we have to do, and I'm going to go ahead and use a highlighter because that'll be quicker, because we have to shade it in. So what I'm going to do is I'm going to look at my map plan, and I see that I have 4 of these spaces are filled in starting from the upper left-hand corner. So I'm going to go ahead and shade in 4 blocks. So everywhere that I have a number that is not 0, I'm just going to shade it in. So notice that all of the numbers in the next one, I can fill those in. And then I have these 2, but I'm going to skip one and fill this one in. Because notice I had a 0 here and I have a 0 here. And then I have a 1 here, and then I have 1 here. And this grid that I gave you actually matches the real dimensions of the example. The map plan didn't, but we just fixed that by going ahead and filling in every space where there are no blocks with a 0. So it doesn't really matter. And it does help if you outline it, although this is not required. If the only type of highlighter you have is a yellow highlighter, you really do have to outline it. Because especially, I mean, even in the regular school, normally I would require my students to outline it because I have a hard time seeing the yellow. But when we're talking about submitting things electronically, sometimes it's even harder to see stuff. So you do want to put an outline around it. But that's what the top view is. That's looking straight down onto the object. So we can see that we have 4, then 5 across, then 2 with a gap, and then 1, and then 1, a bigger gap, and 1. And that matches exactly with what I already have here. Now what I need to do is the slightly more tricky front and right view. So what I want to do from the front is I want to say, okay, and I'm starting in the far left. So I say, okay, well, what's my biggest thing there? Now I can look at the picture, or I can look at my map plan, because the map plan really has the important information. And again, I'm going to use a highlighter so that, because I find that makes it a little easier for me to fill in the spaces. But when I look from the front, what I'm going to see here is what's my biggest number from the front. If I look here, my biggest number is a 4. That means that I'm going to shade up 4. Right? So now what I'm going to do is my big number is 4, so I shade up 4. And so that's the first column to the left. Then my biggest number, and the next one, my biggest number of all of these is a 3. So I'm going to shade up by 3. Then the next one, the biggest number is a 2. So I'm going to shade up by 2. And then my biggest number is a 3. So I shade up 3. And then finally, my biggest number is a 1. Now, I often have students who ask me, well, they say, mine's a mirror image. Is that okay? And unfortunately, it's not okay. Your picture really has to match this one. So I went ahead and outlined around it, and this is basically matches. If I were to look at it from the front, you can see that I have 4 of the red dots here, then 3, then 2, then 3. Because it's kind of big, it's hard to see, but then I have 1 right here. And it has to be this way because they define the front as being what you see when you look at it this way. Now, it would be a mirror image if you looked at it from the back side, but the problem with that is it's defined in the diagram exactly what side is what. And we have to all be on the same page. If we're not on the same page, then your mirror image would be right if you define things differently. But because we have to be able to grade these papers, we have to be able to have the same vocabulary for everything. All right, and then the next one, this is the one that not most students, but the one that more students get wrong is the one for the right side view. And the problem with the right side view, and sometimes with the front side view, is we have to remember, first off, there cannot be, like here are gaps. But if I tried to take a bunch of loose blocks and stack them like this top image here, then these blocks would fall to the ground because they're not being held up. These are not anti-gravity blocks. Because they're not anti-gravity blocks, they have to, we're really going to start at the bottom, and we can't have any gaps. So let me grab a piece of stray paper. So if I were to try to say that this is what it looks like from the front, then this middle block right here is hovering in space, and it will fall down. And if it falls down, then this is not what it looks like. Now, from the right-hand side, part of it helps. This is why kind of being able to visualize what's going on can really make a difference. So if you look at this, this is the top view of this three-dimensional object. We've talked about the front view. Now what we're going to do is we're going to look at the right-hand view. And the right-hand view is literally, when we're looking at this, we're looking, so we look straight at the object from this direction. And so when we're looking at it, the far back, that far back is really what we're seeing here. So that far back ends up being the front right. So that's really what I begin with, is I begin with the very back row to figure out how many to put on my grid. That back row tells me how far up the stack should be starting on the far right. So I started on the far left with my front view. My right view, I want to kind of flip that around a little bit. So what I'm going to do is I'm going to look here, and I'm going to say, okay, starting from the far back, what is my biggest number here? My biggest number here is going to be how many blocks I shade in, and my biggest number is a 4. So I'm going to shade up 4 from the bottom, because we can't have them floating in space. And then the next row, let's see, this next row, that one's going to be the next column. So I'm going to say, what's my biggest number here? My biggest number here is a 2, so I'm going to shade up by 2. And then the next row, This one is going to be what I'm going to put here. My biggest number here is just a 1. So I'm going to go ahead and shade this in. And finally, my last one, because again, we don't care about this one, but this one, my biggest number is a 3. So I'm going to shade up 3 units. So now I have my right-hand view, and then we'll look at the blocks to see if it actually seems to match. Because half of you are in my class, or 1/3 of you are in my class, and 2/3 of you are in Mr. Glidden's class. Now, those of you who are in Mr. Glidden's class probably don't realize it, but I make mistakes. I make a lot of mistakes. However, I love it when students tell me that I've made a mistake so I can fix it and make it better, and in the meantime, you get a laugh at me. So let's take a look. So my image here, my red was the front, my yellow was the top, and then I put green stickers on the right-hand view. And so now what we want to do is see, does it match? Now we've got 4 of these stickers on this side for the first one, and then we have 2, and then we have 1, and then we have 3. 4, 2, 1, 3. So it looks like I didn't mess up, and you can't laugh at me now, but I'm sure there'll come a time when you can definitely laugh at me. Now the next part of this is figuring out the surface area. Now the surface area can be very difficult. Like, we've got this object, and we could start counting up the number of green stickers. And we'd know how many squares we have on this side. Now, just like a dice has 6 surfaces, if you roll a dice, there are going to be 6 surfaces. Each of these cubes has 6 surfaces also, but the only surfaces that matter are the surfaces of the 3-dimensional object. So we don't care about the surface in between these 2 blocks right in here, because that's not a surface of the object. I glued them together. They will never come undone. This was a permanent construction. So what we want to do, I've made a place or a little grid here so you can use this for figuring out the surface area. Now the surface area can be pretty simple except when you have something that's hidden. And so we have to figure out what are those hidden things, but we can leave that until the very end. So first, let's go back to these 3 drawings we made. I know you can't see them very well. I'm going to fix that. So we're going to go back to these 3 drawings, and we're going to try to use them to fill in 6 of these boxes. We'll fill in the last one, the hidden one, afterwards. So if I look at the top view, what I'm going to see there, that's going to tell me exactly how many yellow stickers I had to use to create this object. That's going to be and that's the number of boxes I've filled in. So if I count these up, I've got 1, 2, 3, 4, and 5 is 9, 10, 11, 12, 13, 14. So I go ahead and write that there, but I can go ahead and write it over here. There are 14 surfaces that are visible, and you can even count those up in the diagram. I mean, you can literally count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, hard to see that one, 13, 14 of those green surfaces. So I have those 14, which represents that. And I could turn the whole thing upside down and count those, but it turns out the number from the top is identical to the number from the bottom. So all I had to do was count up all of these shaded regions, put that for top, and duplicate the number for the bottom. So that part was not so difficult. Now what I want to do is I want to do the same exact thing from the front. So in this case, I'm trying to figure out how many red stickers I have here. And you may notice something, like this three-dimensional object. If I tilt it a little bit, a couple more red stickers start to show up. Those are the ones that are hidden, but we're not going to worry about those until the end. So right now, all the ones we want to worry about are the ones that are obvious. Those are the ones that we did in this diagram. So what we're going to do is we're going to count up how many spaces we have here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 in this space. Sorry, that's not the best pen. Trying different pens to see which ones work. So we have 13 here from the front view, and the back view is going to be exactly the same. Now we have to remember that there might be some that are hidden. Now one clue here is we will never have any hidden blocks from the top or the bottom. If they were hidden from the top or the bottom, we'd have to have used anti-gravity so they could float. And since we don't have any anti-gravity, I'm fresh out, so we know there's never going to be any that are hidden from the top or the bottom. However, we are sometimes going to have blocks that are hidden from the right or from the left. So that's right, left, front, back. So that's what we have to ultimately worry about when we get down to here to where it says hidden. So the next thing we're going to do is we're going to figure out how many we have here. And again, there are some that are hiding, but we won't worry about those. All we really have to do is look at our little diagram here and count up the number that we shaded in. So I have 4, 5, 6, 7, 8, 9, 10. And keep in mind, I can count them on my diagram. Like, let's look and see if we come up with 10 here. I've got 1, 2, 3, that little one there, 4, 5, 6, 7, 8, 9. Did I add them wrong? Probably. Let's see. So I have 9, 10, 11, 12, 13. Oh, I see what I did. So when I'm adding them here, you'll notice that I got 10 there, but I got 13 here. So I'm sort of jumping ahead of myself and looking at the things that are hidden. So these are not matching because some are hidden. And it will be the same for the front. So we do have blocks hidden in these two views. We do not have blocks hidden in the top or the bottom view. So that's why those two numbers don't match. And that's a good way to check your work. I told you you'd be able to see me making a mistake. That's my first one. Definitely not my last one. But if there are 10 visible ones that aren't hidden from the right, that means there are 10 from the left. So now what we have is all of the ones that are obvious based on my 3 diagrams here. One way, one hint to let you know that there might be some that are missing is anytime you have a gap like this one, or this one, or this one, that means there's a possibility that there's some that are hidden. And so we can look in the diagram. Some people can look at the diagram and see what's hidden right away. Like when we look from the top, actually if I look from the right, when I'm looking from the right, this block might literally block the one behind it right here. So if I'm looking this way, this yellow surface is going to make this one disappear. So that one that I just shaded in is hidden from the right. And then if I look at this block here, I see that this one has become hidden because there's this gap right here. So this gap shows me things that are hidden. So these two are hidden. And if I keep looking, because remember we counted 13, but we only had 10. So we've found 2 of the ones that are hidden. If I keep looking, I'm like, well, wait a second, here's another block that's obscuring or making it impossible for me to see this one. So I have 3 hidden from the right. I can go ahead and write that right there. So I know that I have 3 hidden from the right, which means I automatically will also have 3 hidden from the left. So on my object here, the green dots are from the right, and if I tilt it, suddenly, so I had these three right here, 1, 2, and 3, and then if I move it slightly, I see this other one. Same thing here, I had only one there, but if I tilt it, I see, aha, there's the other one. And then over here, I have 4, 1, 2, 3, 4. Change the view slightly, suddenly there's 5. So that's the one that's hidden. And you can kind of tell because from the right, you're seeing that there's some, it dips down a little. So there's going to be objects that are going to be hidden. So we've already discovered 6 surfaces that were hidden, and that's just from the right or the left. Now what we want to do is we want to look from the front to the back, see if we can find any other hidden blocks. So I'm going to look at my front view. Now my front view are these gray things, and I counted up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm counting 15, but I only have 13. So we want to figure out what are the ones that are hidden, that are missing, that are somehow obscured. So here is my front view. I've got these red dots, and then so I've got these 4 here, but when I change my perspective, I discover that instead of 4, I've got these 3 and then these 3. So these 2 are hidden. And so if I try to see, are there any others that are hidden? I really don't see them. It's possibly even more clear if you look at my object from the back side. I don't have any stickers on these, but so you've got these are the 13 that we counted, but if I change my perspective any, you see a couple of blue stickers. These 2 are on the back side here, so those are the 2 that are hidden, and they match up with these 2 red ones right here and here. So it turns out that we have this number 5 and this number 6. Those 2 are hidden behind this stack. So we've got 2 from the front, which means we have 2 from the back. So now, in order to find the surface area, the good news is we literally just have to add these all up. So the total amount that are hidden ends up being 10, and now I can add these all up because 3 plus 3 plus 2 plus 2 is 10. So now I can add these up. 4 and 4 is 8, and 3 is 11, and 3 is 14. Let's bring a 1 up. 1, 2, 3, 4, 5, 6, 7, 8. So my surface area is going to be 84, and in this case, my units I decided were called blocks, but these are going to be squared because area, the units are squared, and volume, the units are cubed. I hope this has helped you a lot with example 1. I might do example 2, but a little bit quicker and a lot less talking. But first, what I want to do is try to post this video because it's gotten to be really long, and I apologize. But I hope that what I have said has helped you with understanding this. I pretty much promise you that if you get this example, then you understand probably 25 or more % of everything you need to learn pretty much for the rest of the school year, because we're just going to be doing this chapter and a little bit of review, and then we're going to be done with the semester. If things had gone differently, we probably would have done a couple of additional chapters, but this is all you're going to get, and I'm sure that you can handle that. So I hope this has helped. This is Mrs. Kerfman, and I apologize if I sound like I have a cold. I do, but I'm getting over it.